What's up everybody, welcome back. So in this video I wanted to take a look at the environmental query system, EQS for short, and we can use it to get information from our surroundings to make better decisions for our AI. So I'm going to show you how we can set it up and what we can do with it, and starting from the next video we're actually going to use all of the stuff from this video and from the previous videos to make some working AI. So like a guard or a patrolling AI, for example, and we're also going to make them replicate, so keep an eye on the channel for that. So also, if you like the channel, please make sure to drop a like, and you're also welcome to join the new Discord server. In there I'll drop the links to the videos a day early whenever possible, and I'll also upload the project files and things like that in there. So exclusive for the Discord members. It's free, but if you want access to it, make sure to join the Discord, and let's build an awesome community in there. So thanks for that. So for the EQS system, we need to get to the editor preferences over here and go to the experimental tab and enable it. So over here we have AI environmental query system. Make sure you tick the little box, and after that we can start using it. So if you right click in your content browser, go to the artificial intelligence, and here we have a new environment query. Let's create one and let's take a look at it. Let's open this up. So it looks like a behavior tree, but it works really different. So let's just drag off from here and see what happens. So we can add generators. A generator is simply something that will create points in the map, and later we're going to perform all kinds of tests against these points, and we can determine which one of those points we want to use to walk through, for example, or look at or shoot at or whatever. So first let's take a look at what generators are, and let's add one. So I'm going to add the grid generator over here. And I'm going to leave the default settings. Right now I'm going to save and go back to the content browser, because we can create a testing pawn to see what happens. So let's create a new blueprint, and over here look for EQS. We can create the EQS Testing Pawn, so select that one and let's call it EQS Testing Pawn. So let's give this guy a mesh quickly so we can see where he's at. You don't really need to do this, but it's just a little bit easier. There we go. And let's place him in our map. So let's get the viewport up here as well. So I'm not really used to working on one monitor, so excuse me for being a little bit messy. So we have the testing pawn in here. Let's line him up to the ground. So with your testing pawn selected, if you check the details over here, we can assign a query to the testing pawn. So we have a query template, and let's drag in our newly created query. And to make things a little bit easier, I'm going to disable rerun query only on finished move, so it will automatically update constantly so we can see what's happening all the time. Now let's get back to our viewport, and you can see the grid that's being created immediately. So we have this grid of dots. And those are the dots that we use to perform all kinds of tests later. So first let's get back into our query. And let's take a look at the options we have for the generator. So with the generator selected on the right side, you can specify some stuff like the size and the distance between the dots and things like that. So let me say I'm going to increase the size a little bit, make it 1000 units, and space them out a little bit more, something like this. Now we have to generate around, and that's the context of this generator. I'm going to get back to this in a little bit. So right now we only have the context querier, and that's the actor that performs this query. So in this case that's the AI or the zombie. And we could also set this to the context item, and the item is one of these dots over here. So for a generator, it doesn't make sense to use the context item, and it won't work because we can't generate a grid around a point that's not really in the map yet. So that doesn't work. And right now we're going to leave it to the context querier, and I'm going to get back to the context in a little bit. Let me see. So we have the trace mode over here. Right now we have it set to navigation. So this means the points will try to project on the nav mesh. So over here you see these points bunched up. They should normally be over here, but they are pushed back, so they get inside the nav mesh, And if you move this around, you see it happening a little bit. But we can also select the geometry option over here, and then it will simply project them on our geometry. And we could select a trace channel and even a trace shape for the trace that it's using. And we could also tell how far up and down we want to project it. So for example, if I would set this to 50 units, you see all of these points drop down because they are above the 50 units. So right now they are colliding with this object over here. So you can use it to set up the grid the way you want, and you could also set a vertical offset over here after that, so you can adjust the height of the points after they are being projected. So let me get back to this. Let's set it back to normal, or normal but navigation. So now it's placing them in the nav mesh, and you can see over here they are also placed inside this little cube, although we can't reach them. So it simply means as long as they are projected on the nav mesh, they will be projected, and it doesn't really take pathing into account or something like that. And then we have different options for the generators. So if I look over here, we added the grid points, but we can also add a donut or a cone or a circle. So those are pretty much the same, but they have a different shape. Excuse me. So then we can also add a pathing grid over here, and let's select this one. So now I have two generators in here, and that doesn't work. So it's not like a behavior tree where things get executed from left to right or something like that. You can only have one generator, and only that one is going to work, and you can't add more to them. That doesn't work. So let's get rid of the other one. Oh, that's the wrong one. So let's add a pathing grid. And now you can immediately see a difference. The points inside this square are gone. So it's not going to project them simply onto the nav mesh. It's also going to take the pathing into account this time. So that's the difference between a pathing grid and a normal grid. And again, we can specify all kinds of options over here, like the size and the spacing and things like that. And for the other point generators, we can use tests later on to determine if we can path to them or not, and we can also project them on the nav mesh later if we like to. But for a grid, there's a default option to add a pathing grid, so that's the difference between those. Then we also have a current location generator, so that simply generates one little dot at the specified location. So in this case, that's going to be the querier or the actor that performs this query. And we could also add an actors of class generator, so we can get a set of actors or a single actor inside a certain radius, and we can also choose to discard the radius, and it will project the points on those actors. So I could, for example, say the first person character and increase the radius, so something like this. And now it should project them onto my first person character. Oh, 200, I'm sorry, 2000. So there we go. So now it's projecting the point onto the first person character, and that could also be an array of multiple characters or an array of zombies. Anything you like, you can specify in here. So now we have the generators over here covered. There's one left, and that's a composite, and that simply means you can combine different generators into one. So like I mentioned, you cannot add multiple nodes in here. That doesn't work. So if you want multiple generators, you can add an array over here, and you can simply pick the kind of generator you want to add. So say I want to add a grid around myself, but I also want a generator for the one actor of class, which is the player. So then I can specify those options over here. So that works the same as the generators we just added, but they are stored over in an array on the right side. So that's how you can add multiple generators. Now let's get back to the context that we talked about previously. So I'm going to go back here and add a normal grid generator. So the context was set to the querier, and that's the actor that performs this query. We had the item context, which is not useful right now, but we can also create custom context. So if we right click in the content browser and create a new blueprint. So if we look for context, we can add an environmental query context. Let's select that one and let's open it up. I'm going to call this a context player. And let's see what we can do in here. So we can override 4 functions. There are provide single actor and provide single location, and we can also provide a set of actors and a set of locations. So let's use a single actor for now, and we are simply going to get all actors of class, and we are going to get the player again. So get first person character. Now we're going to pretend this is just a single player game, so I'm going to simply get the first one in the array, and I'm going to plug it into the resulting actor. So now we can use the player as our context, so we can save and close it down. Now if we go back to the environmental query and get the viewport up, so in the drop down menu right now we can also select context player, and immediately you can see it's now generating the grid around the player instead of the querier. So we can still be the guy that asks for this query, but we can place the points around any other actor that we want, or player or whatever. So let's keep the context player over here. Let's increase the grid a little bit, and let's look at the options that we have to work with. So we have the grid, and right now we can right click over here and we can add tests to them. And we're going to perform tests against these dots, and they're going to be scored or filtered out, and we're going to be left with 1 or 2 or multiple dots with the highest score, and we can use them as a result. So these are all the things that we can test against. It doesn't really seem that exciting, but you can get kind of creative with this and still do some cool stuff. So let's go from the top to the bottom. We have a distance test, and that's pretty simple to understand. So let's start with this one. So right now you will see all of these points filled. If they're blue, it means they're filled, and right here in between these brackets you can see at what test they filled. So this is the first test in the array, so it's index 0. So the first test filled all of these dots, and this will actually not provide any result at all. But if we go to the test over here and select it, then we can set it up on the right side over here. So it's set to filter and score. Let's leave it at that for now. And we test the distance to the querier. So that means for each point we're going to test how far it's away from our querier. In this case, that's the zombie. So you have to keep in mind what the querier is and what the context is, because this can get confusing. But right now we're going to test against the querier. So we have it set up to range, minimum 0, maximum 0. So that's why everything fills. So let's say we want a minimum of 200 and maybe a maximum of 1000. And now you can see things changing. So the blue ones are still failing the test, and all of these with a color and a number, they are scored, and the higher the score, the better they get to this test. So if you look over here, it says between 200 and 1000 units, preferred greater. So the further they are away, the higher they will be scored. Now for the scoring, we can change that as well. So over here it says linear, and we can inverse linear. So now it will prefer lesser. So the points closer to me will be scored higher, and further away will be scored lower, up until the 1000 units that we specified, and beyond that they will fail the test. Now we can also say we don't want to filter and score, we only want to filter them, for example. So now they aren't scored, everything score is kept at 0, but all of the blue ones still fail the test, and they won't be used in any other tests that we add later. So that's the difference between a filter and a score, and we can also say score only, so now nothing will be discarded and they will simply be scored according to the scoring we set over here. So this simply means any point closer to me will be scored higher, or any point further away if we change this to linear again. Now we also have an option to say square, so this will increase the so this will increase the ramping up of the number. So this, if you look at the curve over here, so it says linear, square, so that's how the scoring is determined. And you could also say constant, so everything gets scored 1, so that's kind of filtering out maybe. So you can mess around with these settings. Now, right now it said distance to querier, so I'm going to change this with the distance to player. So then it's going to change from scoring each point to the player. And we're going to set it back to filter and score, just like this. So now we have all of the points that are 200 units away from the player up to a maximum of 1000 units, and the ones that are furthest away will be scored higher. And we can continue adding tests. So add another one, and we're going to add a dot, for example. Now the dot, it's pretty much like a normalized value to indicate the difference between two vectors. So if you're not really sure how a dot works, I have a video up about vector math, but you can test against points and see if they are in front or behind the player, for example. So if I select this dot over here, right now it's set to rotation from the querier, and the querier was the zombie guy, but we want the querier of the player, so I'm going to set it to the context player. And then for the second vector that's used in the test, I want the line from the player to the item, so we know what direction the item is in relation to the player. And then we can specify the range over here. So as I mentioned previously, a dot will result a product from -1 up to 1. So for example, if I set the value to -1 and the maximum to 0, all of the dots behind the player will be scored. And you could also change this around. So for example, from 0 to 1, and then everything in front of the player will be scored. Now, 0 is to the left or to the right of a player. So if I want to get to the side of a player, I could say like a minimum range of -0.5 and a maximum range of 0.5. And now you will see it get all points that are to the side of the player. So a dot is actually really useful to determine where a point is in relation to the viewing distance of the player. So we're going to keep them like this, I think. Maybe we can increase it a little bit so we get a bit more results. You want to be pretty careful that you're not filtering out too many points, and you'll end up with failed results constantly. So don't make your tests too complicated, especially not to start with. So let's keep these points. We're going to keep the points that are to the side of the player, and we can resume adding more tests. So right click over here. Now we also have a gameplay text test, so we can see if an actor that we are testing against has a certain tag or not. So right now we are not using actors, but if we have a generator for an actors of class, for example, then we can use a gameplay text test. And over here in the edit menu, you can add your tags and it will check if the actor has those tags or not. So that's how you can use a tag test. So in this case, that's not useful. So I'm going to get rid of it because it will ruin the results. And we have an overlap test as well. So let's add an overlap test. And I'm actually going to drag it in front of the dot test over here. And I'm going to disable the dot test for now, so we can see a little bit better what the overlap does. Now let's select it, and we can simply define it on the right side over here. So it will place a certain shape at the points of each of these dots, and it will see if it overlaps something or not. So right now we have it set to box. I'm going to set it to a capsule, and I'm going to give it the size of the player capsule approximately. So that's about 45-50 units wide. So over here you can see overlap using capsule with a width of 45 and a height of 180. It's going to test in the world static channel, so that's fine. And right now you will see that if I disable the distance test, that everything will return 1. So over here the bool match is 1, so that means that the overlap is actually overlapping something, so the trace is returning true. Now that's because we have a height of 180, so they are colliding with the ground, so we need to raise them up. And now you can see only the ones that are still colliding with actual geometry, those are scored 1. So if we want the points that are not colliding with geometry, we want the trace to return false. So we want the bool match to be false. So select that over here. And now we are left with all of the points that are not colliding with any geometry according to the shape of the capsule. Now we could, for example, add another overlap. And we can drag it like it's right beneath the first one that we added. And I'm also going to set this to a capsule, but I'm going to increase the radius. So I'm going to say 150 and then a height of 180 again. Raise it up 180. And now you can see, because the first capsule wasn't colliding with anything, but the second capsule is, those points are kept. And now all of a sudden we have all of the points that are close to a wall or a cube or something that we can hide behind. So if you use these tests in a bit of creative way, you can definitely get useful information from this. So let's keep all of these points, and let's see what happens if we add the distance check. So now it's also going to filter out the points that are further than 1000 units away from the player. And if we also select our dot, then it's going to keep only the points that are to the left and to the right of the player. Now, as you can see, this gets a little bit dangerous, because right now we only have about 10 results or something, and if we would move around, the chance would be that there are no valid results at all. So, like I mentioned before, you do not want to get these tests to be too complicated, but for the sake of just showing how it works, I'm going to keep it at this for now. So let's see what we can do next. So we have the pathfinding test and a pathfinding badge. To be quite honest, I'm not really sure what's the big difference. If we select the badge option, we have the scan range multiplier, and it says the distance between the point and the context, but I'm not really sure where the distance would be defined at to begin with. So you can mess around with this value a little bit and it will change the result, but I'm not really sure what it does, to be honest. And if I use pathfinding, I normally just use the normal pathfinding one. And with that test selected, we can choose some different options again. So we can say if the path exists or not. So right now we're going to check if a path exists from this point to the querier. So that's the zombie. So can we reach that point or not? So that's fine. We can leave it like that. And again, you can also change where you want to trace against. Let me see. Oh, I thought you could specify the nav mesh. Well, you couldn't. Oh, the filter class, I'm sorry. So you could, if you have different types of nav mesh setup and things like that, you can also specify that over here. So let's keep this in place so we are sure that we can path to these points. And then we have a project test. Well, that's the test I was talking about previously when we added the pathing grid generator and the other ones that don't have a pathing option. So you can use the project to see if something is projected on the nav mesh or projected on geometry, for example. So I'm going to disable all of these tests we added previously, and let's add a project over here. So if we select it, you can choose if you want the navigation option or the geometry option. So then it projects the points on top of the geometry like we saw before with the pathing grid option. And if we set it to nav mesh, it bumps them out. So that's how you can make a circle or a cone or a donut generator also project on the nav mesh, for example. And you can also score this or filter this if you use the project test. So it's kind of like the pathing grid, but then in a testing option. So we don't really need it right now, so I'm going to delete it. And let's enable the ones we had. And after the project, we have a trace test, so we can simply perform our line trace. So if we select it, we can say I want to trace from the point to the querier or for the point to the player, and we can specify if we want the trace to hit something, so then the result will be true, or if it doesn't hit something. So let's see, we have these points over here, and let's say we want to know if from this location we can shoot at the player or not. So we have to test against the context player, because we want to check from the point to the player. And right now it's set to match true, so that means if the trace hits something, it returns a true boolean, so we don't want it to hit something, and then it will return all of the points that can trace to the player. So if we pick one of these points, we can shoot at them as well. And the last test we could add is a volume test, and that simply checks if the actor or the item is inside the volume. So you can specify which volume class you want to use, like a trigger volume with a certain tag, or maybe a volume that you created yourself or something like that. And then you can say if you want it to be inside the volume or not inside the volume, and things like that. So that's a volume test. Let's get rid of that one as well. So we have this kind of weird query setup, but in the end it will return a point to the side of the player where we can see him and shoot at him, and we should be able to reach that point. So let's see how we can use this query in a blueprint. And although that's not really how queries are used normally, for the sake of simplicity, I'm only going to show it in a blueprint right now, and in the next video we're going to use behavior trees and things like that, and that's how a query is used most of the time. But let's simply open our zombie character for now. And if we right click in here, we can look for the run EQS, and we can run a query in here. So in here we can specify which query we want to run. So let's select our newly created query, and the querier is going to be this zombie guy, so that's simply a reference to ourselves. Now we can specify what result we want. Do we want the single item with the highest score, or do we want the best 5% and get a random item from that, or maybe even the best 25%, get a random item from those, or even get all of the matching scores and simply put them all in our array. So if we set it to the single best, then it's going to only return one of these points, and that's probably going to be the 5.27 one over here to the left. So let's keep it at a single best item for now. After this, you need to add a little delay to make sure that the result won't return empty. So I'm going to add a world delta seconds delay. And now we can drag off this result over here, and we can say get query results, and we can get them as actors or as locations. So in this query we generated a normal grid, and that means we are going to return locations in this case. So if we would have had actors of class, for example, and we tested against that, then it could have returned actors. So make sure you pick the right one over here. So I'm going to say get results as locations. Now this is going to return an array, although we only have one single best item over here, but this node doesn't know about that. So I'm simply going to get the first result over here, and that should be our query result. We could add a boolean in here for safety, so if it doesn't return anything, we know what happened. So we can use the boolean for that. Now I have a little movement loop set up over here. It's simply moving the actor to the player location and wait a little bit and then do it again. So I'm going to disconnect this player over here, and I'm plugging in the result from the query, and then make sure that we plug in the execution over here as well. So now it will look for the query result and move to that. So let's see what happens. I need to put a zombie in the map, or this doesn't work. There we go. And there you see, he's moving to a point to the side of me where he could see me. So obviously I'm rotating, so that's why he's not to the side of me, but he is to the side of me now. So you can see the environmental query is working, and he's actually close to geometry all the time. So you could also use this to find cover or hide from the player or things like that. Now, if you enable the gameplay debugger, you could also check out the EQS stuff in here and actually see all the dots and how they are scored and things like that. And there is an advanced view as well that tells the scores and which test returned what score and things like that. So you could really get into depth over there. So that's how an environmental query works and how you can set it up and how you can use it in a blueprint. It can be quite complicated, but if you keep your head around it, so what is the context, what is the querier, and just make sure that you keep track of all of those things, then it shouldn't be too hard if you play around with it a little bit. And if we get into the behavior trees, then it will get a little bit more interesting as well. So simply running the query in the blueprint is kind of just a temporary solution, and normally you would start using behavior trees and things like that at this point. So I hope everything kind of made sense, and I'll see you guys in the next video. Talk to you later. Bye bye. Thanks for watching, everybody. If you liked the video or you think you might have learned something, please consider leaving a like. I'll be back for more.